about some important concept in the cyber physical systems topic, which is related to the privacy of those CPS system and network security. Okay, as you know, when we started our first chapter and we talk about the CPS system, we said the characteristic of the CPS system is to embed or to mix the cyber part with the physical part. Okay, which has the integration. Here we talk about integration of computations with physical work. That means you will find your CPS devices will sense the environment, okay, and collect some data and monitor that data or monitor that environment, and in order to control those physical objects. Okay, you do have something that you control, you want to control, as we mentioned last time, you are controlling let's say the fire, or controlling the level of the water in the barrage, or some types of temperature values, and you don't want to exceed some threshold. So you constantly receive data, you put some devices, some physical devices that will sense the physical environment. And once you get one sensing the physical environment through some types of interconnection between the devices, that data or that sensed data will be sent to the control room, or to the control device or computer, where the data will be processed, analyzed, and appropriate action or command will be taken and sent back to the physical world, or to the machine, or to that device, to do some action, to trigger some mechanical action, to switch on, switch off, open valve, or close valve, and so on. So these are the idea about the physical cyber physical systems, where we do have let's say they are part of what is known as ubiquitous computing. That means you do find them anywhere. Okay, when I talk about CPS, there are plenty of environment where you do find those CPS are everywhere. Okay, on any if you go to any type of environment, at least you will find something that is related to a CPS. Let's say smallest thing is security doors you get inside the campus, or the school, or in enterprise. Maybe you do have some CCTV camera that is considered as a CPS. It is a physical, and it has a computing part that will send live streaming to the control room, where people will control, and based on what they see, maybe they will trigger some action to close door, or to send an alarm, or whatever. This is what we call ubiquitous computing. That means it is found everywhere. Okay, and you can find many other examples to tell you, for instance, that the CPS is part of our life, whether it is at a small scale or at a big scale. Okay, you can find the desktop sensors, laptops, TV, PDA, smartphone, or you can go to a bigger and bigger infrastructure, where we do have the existence of such devices. Okay, and for the vision of that CPS, what the CPS will provide. Okay, because we do have some types of innovation. Okay, there are, if you follow the technology, for instance, it is accelerating at some pace where those CPS should follow. Okay, and those CPS devices, as I mentioned, they can be found in many sectors. Okay, you can go from energy sector to transport sector to building automation, for instance, or health sector, or elderly care sector, manufacturing. Okay, and the CPS are considered as the next revolution computing. Okay, because they are combining that physical part and the cyber part. Okay, and they are providing many benefit to people. Now, why we do have such CPS found everywhere, and they are adopted now in many places. Okay, because of first thing, as we mentioned, the technology, okay, which allows us to use those CPS at on its smallest scale to the biggest scale. The availability of such devices at a low cost. Okay, you can purchase a small sensor with maybe a few reals. You can purchase a small sensor and you can use it, which is our low cost. Low power, they don't consume a lot of power because they are small devices. They do have limited computation, for instance, and they don't consume a lot of power. Okay, a small form, the physical shape, as I mentioned, the smallest sensor. Okay, you have a watch, which is a small form that you can you can take it with you everywhere. Okay, and sensing devices, they do have the sensing capability. Okay, these are, let's say, have contributed to the improvement of the wireless communication. Okay, now using the wireless communication, and we do have the internet bandwidth have been increased. Okay, all those characteristics have contributed to the revolution of the CPS devices, and that's why they are adopted and they can be found everywhere. Okay, and enter different types of models, for instance, and they are used for as a standard security solution, for instance, for using such CPS. Okay, so that's why all those, let's say, characteristics have brought forward that CPS to be used everywhere and at different types of, or we can found it within different types of environment. Now, to understand more the security and privacy issues in CPS, we need to have some types of model. Okay, there are many models. The one we have chosen is, this is our reference model that we are going to look at it, which represent, let's say, an example of a CPS architecture. Okay, CPS architecture model, where we do find in our CPS architecture, or this adopted CPS architecture model, we do have, which is divided into the levels. We do have a device level, we do have a control enterprise level, and we do have a cloud level. Okay, and each level is different from the other level, has its own characteristics, has its own resources that can be found at each different level in terms of the devices, in terms of communication, network. Okay, and these are what we mean by the device, or let's say the CPS architecture model. Now, let's pick up the first part of this model, which is the device level. Okay, when we talk about the device level, this is our device level. What we do find, this is an example, or what you can find at this level. These are smallest, for instance, devices. Let's consider them as temperature sensors, humidity sensors, for instance. These are small devices, and it is the smallest scale in this model, because all those, the other model are, let's say, their size are bigger than this size. Okay, so here you do find some smart devices. Okay, from the smallest part. Okay, let's say these, as I mentioned, sensors, as you might find, for instance, an AC. You might find a fire extinguisher, for instance, a sprinkler. All those devices at small scale that can be controlled over the internet. Okay, and the idea about those devices that are categorized or put in this device level, okay, they do have the task to collect the data, process the data, and communicate that data. Okay, now that data that is collected will be processed by those devices. It might be about themselves, and it might be about the environment. If you can see here, we do have people. These can be found at device level. And we do have devices themselves, are part of the device level. Okay, and as we mentioned, they are collecting data about themselves, or we're going to see later why, or about the environment they are sensing. Those sensors, for instance, temperature sensor or humidity sensor, they are collecting data about the environment where they are located. Okay, if I say this is my room and I have put these types of sensors inside the room, that means the collected data is about this room. The boundary of these devices is this rectangle, dotted rectangle. Okay, and sometimes they do have sometimes some devices that are at this level, which is device level. They might have some relation to some actuating technology or some actuators where they can control the physical environment, like what we mentioned in our previous chapter. You do have that sensor that is sensing the level of water in a barrage, for instance, and that sensor is related, for instance, to an actuator that will receive a command to trigger some mechanical action to close or to open a valve. That's why we say within this environment or within this level, which is the device level, we might have some actuators. On top of the sensors, we might have some actuators. Okay? However, when we talk about those devices, because they are small devices, what do you think about, do they have any limitation, Shabab, ولا لا? Do these devices have limitations where they are because they are in the device level, or they don't have any limitation?
Maybe a limitation.
Limitation.
Maybe a limitation in what they can receive as input.
Okay, something that is related to the devices themselves. Anything else as limitation?
Because of the barriers around them, yani.
Not the values, the devices themselves.
Barriers. I mean the
Yeah.
barriers.
The barriers, not in that one. Anything else?
Computation chips.
Good. Yes, because they are small devices. They are made of small chips. What is meant by you do have small chips? Which means what? If you compare this device, small device, with a bigger device, what can you say about
different capabilities? Yani.
Capability on what? This is what I'm looking for. Capability related to what? Computation. What else? Computation, that means we are talking about the processing power, the CPU. What else? What other limitation which is related to capability?
Range, maybe.
Range, yes. What else? The range is not a problem, because usually when you put some sensors in an environment, you are sure that the sensor, they do have some range. Okay, you are covering that range. And when you go to the other range, you will put other sensors. So what on the top of the CPU as a limitation, where we talk about low processing power? What else?
A need for a human element?
No need. We don't need human element. But when you specify CPS, we sell those CPS devices like sensor. They might be dropped by a helicopter in a harsh environment. Okay, where people cannot access that environment. So we don't need human interaction. Just think about the process, the device itself in terms of hardware, for instance.
Easily destructible, maybe.
Okay, we're talking about limitation, not challenges. Yalla, you talk about CPU. What else in computer you do have? What can be a problem with your mobile, Shabab? When you go to purchase a mobile, what are the specifications you will look for?
High battery. Maybe.
High battery, good. That means they do have, these devices have limitation in the energy, because if the battery dies, that means that device will no longer work. Okay, what else? You will look in the mobile phone. The same thing with those devices.
RAM.
Memory.
Okay, they do have constraint with respect to the available memory. Okay, the memory is limited because they are small devices. That means they are made of small chips, small component. That means they do have some restrictions, some constraints with regard to the processing, the CPU. We cannot have the top higher, let's say, quickest CPU. We cannot have highest memory. They are limited. Maybe we cannot exceed. It depends on the device, but we cannot exceed some limits of the memory, like when you purchase or where you put a standalone device with a standalone computer. And they do have the problem with the battery, the energy, because there are devices, wireless devices. We are putting those sensors, for instance, in a harsh environment. They are not connected to the power, like where you do have in an infrastructure or a home or a building where you do have connection to the power. You have a source of power. These are like your mobile. Okay, after limitation, the battery will die 7 hours, 9 hours, depends on the activity you do on your mobile. But at the end, the battery will last, will end. So you need to charge it. However, these devices, if they are put in a harsh environment when people cannot access, or it is difficult for people to access those devices, that means we rely entirely on the life of the battery. If the battery has a life, for instance, 2-3 years, for instance, okay, based on some activities, okay, that is done by those devices, that means after 2-3 years, we will no longer receive data from those devices. Okay, they will die because of the power. So these are some limitations of those devices that can be put in the device level. However, okay, in the other side, we do have some positive things. Maybe they are cheap because they are small devices. They might be considered as cheap devices. As I mentioned, you might put them because they are cheap. For instance, to cover this area, I will put maybe 100 devices, 100 sensors to cover the whole area. Because they are cheap, I can buy them. Okay, I do have, for instance, let's say if it is R1 for each sensor, I might buy 100 sensors. Okay, and I will put them in some specific area, distribute them through that area in order to cover each 50 centimeter, for instance. Each meter, I do have one sensor covering that range of, let's say, a square meter, for instance. So that means, beside those limitations we do have on those devices, we do have also some good things that are helping, okay, to deploy those devices at a large scale. Okay, Shabab? And also what we do find in this part here, we said that these devices, okay, they are forming a network. Okay, they are forming a network of small devices. That means all those devices are communicating between each other. Then they will go to this device. You're going to see later what is this one, which is gateway. Okay, so at the end, these devices in the network topology we do have here, we say that these devices are forming edge networks. Anyone has an idea about what is edge network, guys? This is an idea about networking. Sometimes, let's say you do have a data center, for instance. I do have one data center where all the computations and operations are done in the data center. And we don't want, for instance, to create an overhead on the devices that are within our data center. So what you will do, you will create, for instance, let's consider this is the data center. Okay, to alleviate the number of operations and to overcome the overhead induced by the number or huge number of operations, what we do, we create another network. We put some devices on those on that network. That network will be not far from my data center. Why? And I will let that network, which I will call edge network, to do all the computation task. Okay, that means I will move the computation task from the data center to another network, which I call edge network. It will not be far from the center, data center. So all the computation will be done and the result will be sent directly to my data center. So here in this way, I will have the data center to do its own specific task, and all the burden of the operations or computations will be done in another network or networks, not necessarily only one. I might create many edge networks, okay, where I will do all the data, okay? Instead of combining, for instance, this control enterprise devices, okay, at this control enterprise level, we do have some devices. Instead of putting these devices with these devices combined together in one place, what we will do, we will separate them. These devices will have some specific task, collecting data, processing data, for instance, then gathering data and sending data to be analyzed. Okay, instead of letting the task of collecting data, sensing the environment done by those devices, no, we just separate them. We let these devices to be to do some specific things, okay, and we let the other devices, okay, that are put in the device level to do more specific tasks, and we call such network as an edge network. Okay, it's like for instance, you do have some routers, specialized router. Those specialized router will put in edge network to do some specific specialized task, for instance, that cannot be done by other devices at another level. Okay, maybe this place, or let's say those edge network have some specific characteristics in terms of maybe routing capability, or caching, or storage, or whatever. Okay, but in IoT management, it is very common to find this type of edge networks where those IoT devices are put in one place, and we do have other places that will do other tasks. Okay, so as we mentioned, for this edge network, okay, we do have what is known as low power. They are linked. Those devices are using a wireless network. Mostly they are using low power IEEE 822.15.4 standard. This is the standard for the wireless communication. Okay, sometimes you do have that network, that wireless network is complemented and it is added or is helped by another type of structure or network design, which is a ZigBee network, which is related to the network or wireless communication, and the IP version 6 low power wireless private area network, or what a private area network, where we'll see later what are some specific tasks or some specific what is the reason for using such techniques, or that low power or IP version 6 over low power wireless personal area network. Okay, so here we talk about when we do have IP version 6 protocol, okay, and working on some specific area because it is using low power. That's why it has been chosen. It is not consuming a lot of power because, as we mentioned, those small devices that are put at this device level, they do have limitation on power. So we don't want to use any protocol of communication, okay, or communication protocol that will induce an overhead, will induce a lot of operations, will induce it will consume the energy of those devices because they are running ABC protocol, because we do have a limitation in power. So we don't want, for instance, this device that has been put in this environment to live there for 3 years, for instance, and you will find at the end of the day those devices will run out of their energy or battery energy in a few months, because the chosen protocol was not the appropriate protocol that should run in this edge network. So it is very important to consider the appropriate protocol that will run inside that device level or inside that edge network, in order not to consume or not to create an overhead and consume a lot of energy. Okay, and this is an example of what you do have, for instance, in a smart home. Okay, in smart home, you might find some devices are using IP version 6, for instance. So what type of power? You will use version 6 low power wireless personal area network. Okay, this is the way of, let's say, the protocol that you will use, for instance. Okay, and this is the idea, but because these are IoT devices, they do have those limitations that we have mentioned previously. So it is advisable to use something that will not consume a lot of. This is to show you just the small scale of those devices. Okay, there are small devices that can be put, and also you will find some industrial protocol. Okay, this is an example of a wireless highway addressable remote transducer protocol. This is a protocol that you do find in industrial environment, where it communicates, or it is used in communication between one machine to another machine, for instance. Okay, and as I mentioned, for the ZigBee, as it is an IEEE 802.15.4 technology or specification for the communication, high-level communication between those different small, low-power devices. Okay, and usually you do find it in medical device data collection and small the sensors and so on, because they don't consume a lot of energy. Clear for this part, Shabab, for the device level?
Clear.
We move on to the next level in our model, which is the control and enterprise level. Okay, here what we do have an internet backbone. What is internet backbone, Shabab?
Is the thing that above the internet service provider, right?
Yes. So what is the task of the internet backbone?
They bring the internet, basically.
They will link. Okay, they will link different networks together. They are put. You put, for instance, the high processing routers with high power, with high memory, for instance, and so on. So they will link, because you need to transfer data quickly. Okay, between one level to another level, between let's say your network to the internet. So you need those fastest routers to process your data, to send your request and get you back in quickest way the response and the reply. Okay, so we define this control enterprise level. It is put in the internet backbone. This is for the device level. We do have constrained edge networks. Here we do have those servers, okay, where you do find those types of devices that are usually connected to the gateway router. Okay, as I mentioned here, these devices that are put in the control enterprise level, they are connected to the gateway that will link them, that will create a bridge or a link between the device level and the control level or enterprise level. Those devices will collect the data, and they will sense the data. They will send it to this control enterprise level via that gateway. Okay, and what we can find also in this way. Okay, you will run, for instance, you will find in this control level, you will have some servers, okay, that are controlled with a backend server that will have, let's say, the capability of controlling and analyzing data. They would have the task for controlling and analyzing task based on the data they are collecting. Okay, the data is collected. It is sent to those servers. Those servers will run some algorithm. They will analyze data, and they might use. They will send some command or some actions to be done on the physical world, for instance. Okay, here for the server in this level, or control enterprise level, we might have one server and we might have mini servers that can be linked together. Okay, you might have here a different level of servers. It depends on the role of those servers or the task. Okay, you might have one level of servers connected to another level of servers. Okay, through an enterprise site, for instance, with an interface where you do have that specific type of connection between servers. This was the basic framework, basic model for the CPS. With the advance and the creation of the cloud, okay, a third level has been added to the CPS model, which is known as the cloud level. Here you do find many public companies and private companies that are relying on the cloud services. Okay, instead of storing and analyzing data within the server, they will rely on the cloud service where the data will be stored on the cloud. It will be processed on the cloud and analyzed on the cloud as well. Okay, so that means you will have here a number of, which is a cloud services, when you do have data network or data center networks inside it, where all the processing might be done at the cloud level instead of being done at maybe at the enterprise location where they do have their servers. They will not do that. They will just process, gather data, and send it through the internet to the cloud server, or at the cloud level where you do have cloud, okay, architecture. Now, when we talk about the cloud level, we might have the inter-cloud communication. You can see here we do have inter-cloud. That means one cloud is related to another cloud, and so on. Okay, you do have inside the same cloud, you might have a layered architecture. Okay, you do have, for instance, a platform as a service, software as a service. That means inside the same cloud, there are many layers, architecture, and each layer is done or is related to some specific task to be done within that cloud layer, for instance. And also, what we do have in the cloud, we do have something else which is known as multi-tenancy. Okay, when we talk about multi-tenancy, what is meant by multi-tenancy? Anyone, Shabab? Any idea? Which is related to the cloud? What is tenancy? Any idea, Shabab? When we say we do have a cloud service, okay, let's say consider this is a PSU network, okay, and PSU is relying on the services provided by STC Cloud. Do you think that now that STC Cloud is provided only, or STC is providing its cloud service only to PSU, or it is also providing the same service to other company?
To others?
To others as well, okay? Because they are looking at the business wise. So they are providing also their services to other companies. That means you will find the same cloud is shared by many other companies. This is what is known as multi-tenancy. As PSU, I will sign an agreement with STC Cloud. Another company will sign with the STC Cloud using the same cloud, using the same service. We are connecting to the same cloud. This is what is known as a multi-tenancy. That means the cloud, by its characteristic, it is considered as a multi-tenancy because we are not having our own cloud, because it does cost you a lot of money, and so you have to have, let's say, the budget to hire on your own, to have your own cloud dedicated for you. but most of the company now they share the same cloud service. Yes, I've heard the
دكتور
question.
مو هذا threats يعني in terms of
Yes, we're going to
privacy.
talk later, Shabab. Yes, we are going to talk inshallah about each threats at each level.
Okay.
Okay, Shabab. Any question till now, Shabab?